Mic check. Right, I like this page. Seems like we're going to differentiate, integrate, draw, and standard deviate. I feel like this is a very achievable page. Speaking of pages, let's add one. What are we up to? 18. Oops. Okay. Okay. Derivative of ln 5x. Okay, well that's just derivative over original. So that's equal to 5 over 5x, which is the same as 1 over x. That was easy. Are these all one mark? Yeah, they are. Okay, b equals, what do we got? Cos 5x. Okay, derivative of cos is negative sine. I keep the inside, and I times by the derivative of the inside, which is 5. That's just minus 5 sine 5x. Easy. C. 5x squared. What? 5x all squared. Okay, so that's the same as, so let me just rewrite that. That's the same as 25x squared. I guess that's a common mistake. So that's equal to 50x. Wow, this is easy. Ez. We got derivative of 1 on x. I guess the common mistake is people might get it wrong around and say ln x, but that's not correct. So I always just rewrite that as x to the minus 1 and then differentiate it. So I bring the minus 1 down, I drop the power, and then I like to, I guess the textbook only rewrites it like using power notation because that's how the question is given to you. It doesn't really matter, it's a 1 mark question. But I can just write it as minus 1 on x squared. It's the same thing. Okay, 19. I'm going to do up to question 24, including. Okay, integrate 2 on, does that say root x? Is that just x? 2 on root x, okay. So the integral of 2 on root x dx, just going to rewrite that. I'm going to bring the 2 out. So I'm going to write that as x to the minus a half. And I should be able to deal with it. So 2 times, okay, so I raise the power and then divide by it. So raising the power gives me a half. Dividing by it gives me 2. Move. A. B. Integral. What is it? 7 and 1 on 7x plus 5. 1 on 7x plus 5. So yeah, respect to x. Okay, so fraction is always derivative over original. Now I want the derivative of this to be on the top. So the derivative of this is a 7, which means I want there to be a 7 on the top. Okay, but I'll put it there. I've times by 7, so I need to divide by 7, and now I'm good. So 1 on 7, and then it's ln the denominator. And that's fine. Plus C. Leave it like that. Okay, consider the function blah blah, sketch it between 0 and pi. Okay, that should be achieved. The question is 20. Yeah. Have I missed a page or something? I feel like this is very fast. 17, right? Okay. 20. A. I'm making a sketch. How good am I at drawing sketches? Not very. I remember that lesson. Pi. So I just think what does sine normally look like? So I'm just going to draw a quick little doodle up here of sine. Sine looks like that 2 pi. Okay, so a couple of things I'm going to take away from, I've got y equals 2 plus 2 sine 4x. Okay, so the maximum, okay, so it's up 2, but it's also got a raised amplitude. So the amplitude equals 2. So the max height is going to be, because it's raised 2, it's going to be 2 plus that. So it's confusing because they're all 2s. It's 2 plus this and 2 minus this. If that kind of makes sense. What has it got? Example. Okay, if this went to, if this went to 2, and it's being raised to, it's going to go up to 4 now. It's going to go, the max height is going to be 2 plus 2. Now, if it went down to minus 2, and now it's being raised to, it's going to go, yeah, so it's 2 minus 2. The min 2 minus 2. So that's 4, and that's 0. So we'll call this 4, call this 0. Now, it's, what am I doing now? I want this 4, so the period. So the period is 2 pi on n. N is this thing, so 2 pi on 4, which means pi on 2. So the period isn't 2 pi, so in other words, it does this over pi on 2. So if I draw a pi on 2 here, it goes through this whole motion in here. So it's going to look like, if I've drawn the picture wrong, that's because sine looks like this. Sorry, that's sine. Okay, so it's going to do that. So that and that. So it's actually going to start here at 2, go up, down, up. Okay. What a beautiful picture. Okay, so it does that from there, which means now I have to do it a second time. Actually, I'm going to keep that. So my little screw working out. So I'm going to do that again. So up, down, up. Just taking this off. Okay. So there's a couple of things you can take away from this 4. It's one, you can take away the period, so it does its thing to there. But also this 4 tells you it does its thing 4 times in the normal domain. So like this is our normal domain. It's going to do that 4 times. And here it's done it twice, but I'm only got a pi. And the other one's 2 pi, so it's kind of double. Okay, so that's what my graph should look like. Check out the answers. Yes. Okay, so sketch the graph. Oh, done. Okay, that's A. B. What marks is that? 2. Yeah, fine. Use your sketch to solve the equation sine 4x equals 0. Yeah, right. How am I going to use my sketch to do that? That's a bit stupid. Okay. Well, in my case, when does this equal 0? Well, it equals 0 when, so hang on. Let's call this y equals sine 4x. Call that y equals 0. Now my graph, it's kind of confusing because my graph's like double that. So when I'm using my sketch, it's going to be a little bit differently because it's considering it hasn't, like this graph hasn't been moved up, but mine has. So considering mine's moved up, you can think of this as being, so if I had y equals 2 plus 2 sine 4x, I've just got to cater for a change. So like my change is that it's been moved up. Don't worry about the amplitude too much. It doesn't really matter where, like how much it's been scaled. It's kind of when it crosses this. So if you imagine you just had a normal sine, it doesn't matter if it's this or this, it's still crossing at the same points. It's just a matter of this plus 2. So I'm going to have to raise this plus 2. So y equals 2. So what that kind of means is I'm looking for these points. I hope that made some kind of sense. I've essentially just changed where the axis is. So I'm looking for points where I guess these cross. So there's a few of them. So the solutions, how many times does it cross? It crosses 1, 2, 3, 4, and 5. We include that because in the question it says less than or equal to, so that's why we do include this and this. So to figure out where they occur. Well, we can use that sketch, but we don't have to. We could literally, if you didn't have a good sketch, you could just solve this. That wouldn't be that hard. But considering I've got a sketch, I know that this point is pi on 2, I know that that's 0, I know that that's pi, and I know that these are halfway, so that's pi on 4, and that's 3 pi on 4. So that's not too bad given my graph. But if you didn't have a good graph, you could just go, okay, well, when does this occur? Well, it occurs when this equals 0. So you would just do, you'd go through your table and you'd be like, okay, when does it equal 0? And you just divide each of your values by 4 and you end up with the same thing. So I'm just going to look at my graph. So I know, do it in red. I know that that's 0. I know that that's pi on 4. I know that that is pi on 2. I know that that is 3 pi on 4. And I know that that's pi. That's it's a kind of hard question, I suppose, but it just relies on you having a decent picture, because if you didn't have a decent picture, then you're kind of screwed. Okay, next one. Do I have enough room to... Probably not. Add a new page. Question is that 21. Alright. It's found that the wait times of patients see a doctor and medical center are normally distributed. That's what I need. That's standard deviation. Find the probability that the patient will wait more than 15 minutes. Okay, so this is a type of question where I draw a bell curve. Let's just draw a terrible one. Now my mean is, what's the mean? 17.6. Standard deviation is 5.2. So, oh geez, what's that going to be? 17.6 plus 5.2. 22.8 plus 5.2. Oh, damn it. That's 28. Okay, let's just go to 2. What's my more than 15 minutes? Okay, so I don't actually care about these. They can go away. I care about these ones. So 17.6 minus 5.2. That's 12.4. Okay, so that means 15 sits in here somewhere. What's the bet it's right in the middle? Let me just work out the z score. So z equals x minus mu on that. That's 17, no. The score was 15. 15 minus 17.6 over 12.4. Why did I write 12.4? The standard deviation is 5.2. Uh-oh. It's better. Okay, that's a negative a half. So negative 0.5. Okay, so that's exactly 0.5 z score. So yeah, right. I'm gonna need my table. Damn. Does the question give me a table? How do you do this without a table? Well, I don't know how you do that without a table, so that's kind of interesting. How would I get 0.5? Surely there's a table at the end of this. There's not. Wow, okay. Sorry folks, I don't know how to do that without a table, but it would be... Anyway, what's this actually asking? It wants to probably wait more than 15 minutes. So they want all of this. The table would give me like this side. So I'd have to do 1 minus this side. So my solution is going to be 1 minus the probability that z is less than negative 0.5. That seems alright. Okay, so the probability that z is greater than minus 0.5. And that's kind of as far as I can go because I don't have the table. I don't know why the question would give me the table. Oh well. It says here 1 mark goes to this, the second mark goes to this, and the third mark goes to the answer. So we'll leave it like that because I'm not given enough information there. Unless I'm missing something. Okay. Here's a parabola. Line. Solve simultaneously, find the points of intersection. Okay, that's really easy. 20, what have I got? 22a. So I've got the line y equals 2x minus x squared. And I've got line y equals minus x. I want to know where they cross, so I just set them equal to each other. 2x minus x squared equals minus x. I'll move that over. So don't divide by x in this case, otherwise you'll miss a solution. So that's going to be 3x minus x squared equals 0. So then factorize. So that's x outside of 3 minus x equals 0. That means x equals 0. And 3 minus x equals 0, which means x equals 3. Now I have my two, does I want points? I want points, okay. So then I substitute each of those back into wherever I want. So this tells me I've got the point 0, and then if I just chuck a 0 in here, that gives me y equals 0. And here, 3, I chuck a 3 into here, that's going to give me minus 3. There are my two coordinates. It did ask for points, so I'm just going to run as coordinates. Okay, B. What does it want now? Finds the area of the region enclosed by P and L. Okay, I think I need some room for that. Let's draw what that looks like. So, just draw that. 2x minus x squared. Gee, I don't know what that looks like. I know it casts at 0. Let's just draw minus x. Minus x looks like that. Now, my intersections are at 0, 0, and 3 minus 3. So here, I know this is a parabola. If they cut there, it's also a negative parabola, so it's going to be upside down. So it's going to look like that. That's pretty good. So I'm looking for this area. Okay, is that all it wants? The area of the region. Okay, so what I'm going to have to do, now I also know that, oops, that is 3, and we see that's 0. So I'm going to have to find two integrals. The first integral I find is this one, and the area underneath the curve there. So let me get rid of that. Let's call this area 1. Area 1 is going to be the integral from 0 to 3. Oh, hang on a minute, no, I can't do that, can I? I'm going to have to go from... How am I going to do that? I'm going to need the x-intercept, won't I? Oh, I'm overthinking it. Okay, so because this one is on top of this one, I do this graph minus this graph. Okay, I forgot what I was doing there. So that graph minus the other graph. So that's for any two functions. If you're trying to find the intersection, you do the top graph minus the bottom graph. Top graph, bottom graph. I don't know where I wrote A1 there. I don't know what I was thinking. Okay, dx. Let's simplify that. That's 2x. Oh, I'm missing a squared somewhere. 2x, holy moly, there's a lot of minuses. 2x minus x. That's 3x minus x squared dx. I integrate that. I raise it divided by, so 3 on 2x squared. Raise it divided by minus 1 on 3x cubed between 0 and 3. That's going to be 3 on 2 times 3 squared minus 1 on 3 times 3 cubed. The whole rest of it's going to be 0, so that's minus 0. And okay, 3 squared is 9. 9 times 3 is 27, so that's 27 on 2. Minus now 3 cubed. That's 27 on 3. God damn it. Alright, that. Oh, hang on a minute. Yeah, 27 on. Okay, that's just 9. Well, 27 on 2 minus 27 on 3. 9 on 2. Yeah, that's great. Okay. How many marks was that? 3 marks. Yeah, right. And the simultaneous equations is 1 mark. Interesting. Okay, oh, this is all the questions I've got left. 19 minutes. Not doing too bad. Okay, 23. Need to split up. Yep. Okay, series and sequences. Okay, what am I told? T. I need some ingredients. T6 is minus 10. T21 is 50. And, oh wait, that's an, yeah, right. Okay, so that's a arithmetic series. And then there's an infinite geometric series, T1 equals 32, and common ratio 3 on 4. Okay, and that's a GS. I don't like that G. GS, okay. Oh my god, I'm out of room. Go away. Page. Alright. Find the limiting sum of the geometric series. Okay, that's easy. The limiting sum is A. 1 minus, how many markers is this? 1, is that it? Okay. A is, well, they told us what the first one is, it's 3 on 2. 1 minus 3 on 4. I type that into the calculator, and off the complete top of my head, I get 128. Okay. B. It's not well enough. B. Show that the sum of first n terms, okay, so the sum of first n terms is that thing. Okay, so it's proof. Oh, so they told me, so that's kind of nice. First, now that's the arithmetic series. So my sum formula is, geez, what is it again? It's something like, no, n on 2, isn't it? N on 2, 2a plus n minus 1d? I'm pretty sure that's what it is. God, I've got a good memory. Just kidding. What was I just doing? Okay, now let's start filling it in. So I don't know what n is, do I? Oh, that's yeah, okay, so that's blank. What am I aiming for? I'm aiming for 2n squared minus 32n. Okay, that's what I'm aiming for. Is my aim. Okay, let's start subbing stuff in. I don't know where it starts. Also don't know what D is. Well, that's great. So there's actually there's a couple of things I can do here. All they told me is these two things. So I'm going to draw them out. I'll come back to this. T6 is equal to minus 10. Now that should be equal to A plus n minus 1d. A plus, now I know it's sixth term, so that's 5d. And guess what? I'm going to call that equation 1. I know that T21 is 50. That's A plus n minus 1, which is 21 minus 1, which is 20d. I'm going to call that 2. Now, both of these have an A in them, so I'll do 1 minus 2, or 2 minus 1 will give me positive numbers, so I'll go 2 minus 1. That's going to give me, okay, so 50 minus 10 is 60. A minus A is nothing. 20d minus 5d is 15d. That means d is equal to, damn it, 60 divided by 5. I should know that's 4. Idiot. Okay, and then I'll call that 3, and I'll put 3 in 1. That's the smallest numbers. That's minus 10 equals A plus 5 times 4. That's A plus 20 minus D. That means A equals, can't do that in my head, minus 30. What's that? Plus 20? Yep. Okay, so therefore, A equals minus 30, D equals 4. So going back to this, I've got Sn equals n on 2a is minus 60. N minus 1, I don't know what it is. N minus 1 times 4. Okay, let's keep going with this. My aim is this. We'll leave my aim up there. I'm going to have a choice. See you later. Okay. N on 2, that's like minus 60 plus 4n minus 4. And on 2, minus 60 minus 4 is minus 64 plus 4n. I'll expand, so I have to divide them by 2. So that's going to be, let's just do that first. So that's going to be minus 32 plus 2n. Okay. So I got rid of that half. So on 2, on 2. And then that's minus 32n plus 2n squared. Is that what I wanted? Minus 32n plus 2n squared. And then I'll just write still as required. Cool. Is that it? No, there's a C. God damn it. C. Dot's really small and triggering. Find the value of n for which the sum of the arithmetic series is 3 times the limiting sum of the geometric series. Okay, let's write that in maths. The value for which the sum of the arithmetic series. Okay, well, the last question just made me prove what that is. So the sum of that is 2n squared minus 3. That's what I just was told that the arithmetic series is. I want that to be 3 times the limiting sum of the geometric series. Now, the first question made me do that. That was this 128. So 3 times 128. And I want the value for n. Easy. 2n squared minus 32n equals, what's 3 times 128? 8, 384. Move everything over. 2n squared minus 32n minus 384. Everything's even, so let's halve everything. So that's n squared minus 16n minus, I don't know, 192. These look like really nice numbers, so I bet you this factorizes nicely, but I can't think of anything that might go into them. So I'm going to use the quadratic formula. N equals minus b plus or minus the square root of b squared minus 4 times a times c, all on 2a, which is just 2. Now, 16 plus square root of 16 squared plus 4 times 192 on 2, that's 24. Oh yeah, of course, is a nice number. And then I'll do the minus case, that's minus 8. What was the whole point of this? Find the value of n for which, oh okay, well n can't be negative. So since n has to be positive, n equals 24. Done. Okay. Apparently this factorizes nice, which I guess is easy to see there, but I would never have known that 24 times a is 192. Anyway. One more question, 24. We're out of time. Not even half an hour yet. Killing this paper. Okay, 24. Oh jeez, probability. Year 11 probability. A fave. In a bag there are 4 red marbles. I have to write this. 4 red, 3 green, and 3 yellow. That's terrible, disgusting. 3, I hate when people write 3 like that. 3 yellow. 3 marbles are chosen at random without replacement. Determine the probability that all 3 marbles are yellow. Let's just say without replacement. I guess you could draw a tree, but don't really need to. The probability of yellow, yellow, yellow. Is that what it was asking? 3 yellows, yeah. It's going to be, okay, what's the probability of it happening once? That's going to be 3 out of just 10. The probability of happening twice would be 2 out of 9, and then 1 out of 8. I hope that makes sense. So there was 10 in total, then there was 9, then there was 8, because I haven't replaced them. There was 3 yellows, now there's 2, now there's 1. So type all that in, and I get 3 on 10 times 2 on 9 times 1 on 8, 1 on 120. 1 120 chance of happening. B. At least one red marble is chosen. Okay. Whenever you have a question that says at least one, do 1 minus it not happening. So 1 minus the probability of no red, which is going to be 1 minus, and then you use brackets because you're going to have to look at obviously the 3 cases. Okay, so the probability of not selecting a red your first go is going to be everything else. So 6 out of 10. 6 out of 10. Then there'll be 1 less. So 5. So it's just 5 out of 9. 4 out of 8. Why did it take me so long to go 9 minus 8? Okay, and that's equal to 1 minus 6 on 10 times 5. 9 times 4. That's 5 on 6. Oh, so it's pretty high chance you can get at least a red, which that actually kind of makes sense. That's why I was thinking about it so much. Okay, and C. Alright. 1 marble of each color is chosen. Probability that 1 marble. Ooh. This is going to require a tree. Damn it. Okay, screw it. You've got 3 things. So 1, 2, 3. Off that, I've got 1, 2. I'm going to run over 1, 2, 3. 1, 2, 3. 1, 2, 3. And each of those is 1, 2, 3. 1, 2, 3. Yuck. Oh, this is an extension 1 question. Red, green, yellow, red, green. Okay, did this say without... this question sucks. Okay, well, screw that up. Right, let's just look at the cases. The probability of getting a... Let's do it in the order of the question. R, then a green, then a yellow is going to be... Okay, so that's 4 out of 10. And then green will be 3 out of 9. And then that'll be 3 out of 8. I hope that kind of makes sense. So it's 4 reds, 3 greens, 3 yellows, but each time I'm taking one out without replacing it. Now I've just got to think of all the cases. So the probability of... Oh, it's going to be 3 factorial. But the probability is all going to be the same. Okay, let's just do R, Y, G. That's going to be 4 out of 10, and then the other two are just going to swap, so this will be 3 out of... Oh, it's going to be the same. Okay. I really don't want to do this using extension 1 stuff, but I'm gonna. No matter what you do, like if I chose red to be second, this would just go like this. And it doesn't change the value of it. So in other words, I just need to think of how many different ways can this happen? Like how many different arrangements are there? Like I have red first, then green, yellow, or red first, then yellow, green, or green first, and then like how many are there? So if you just list them out, I can have Y, red, green, and I can have Y, green, red. Then I can have what, G, R, Y, and then G, Y, R, angry. So the 6 of them. So all I need to do is go like this times 6, because at the end of the day I'd be adding all these because they're branches. So, or I could just go that times 6. So that would be what I would do. But yeah, it's a 2-mark question. I think that's a little bit mean for advanced. I can certainly see why it would be an extension question. I don't know. 309 times 308. That's 310. Okay. And that's it. So if you were drawing a tree for that, that would be a pretty large tree. The answers use combinatorics, which is a little bit stupid. But yeah. Anyway. Oh well. Alright, well that's it. How long did that take? 35 minutes.